Good morning, students. Today we will talk about the reflection of waves under the waves as a subtopic. The reflection of waves is almost similar to the reflection of conventional reflections we just study about in case of light, in case of sound. So today we will talk about more in deep about the reflection of waves. Now under the waves we will just talk about both the transverse and the longitudinal waves. As we experience in our daily life of life reflection of sound waves from a rigid boundary, and the phenomena of sound waves reflecting by any rigid body or a wall is known as echo. Now if the boundary is not completely rigid, or it is an interference between two different elastic media, it depends on their density basically, then the effect of boundary conditions on an incident pulse or wave is somewhat complicated. Now, a part of a wave is reflected and a part is transmitted into the second medium. Now, if a wave is incident obliquely on the boundaries between two different media, the transmitted wave is called a refracted wave. So, this phenomena we can understand through a graph. Let us suppose this is a rigid wall by which there is string, and we just shake this string. So, what happens? A pulse is generated in this way. So, here is the left end of the same string will be tied in this way, like this. Now if the pulse is moving in this direction, then it will be shown as, now in this case there is no pulse or wave is generated, so it's more looking like a straight wire. Now after the reflection, the same pulse or wave return in opposite direction, and the phase will be exactly opposite to the same. Now this will be shows as a reflected wave. Here in this case, side will be behave like this. Now this will be a figure A, and this will be a figure B. In this figure A, a pulse incident from the right, pulse incident from the right, incident from the right is reflected back, is reflected at the left end, at the left end of at the left end of the string, which is tied to a wall, which is tied to a wall, which is tied to a wall. Note that the reflected pulse inverted from the incident pulse, inverted from the incident pulse. Here the left end is, in case of B, here the left end is tied to a string, is tied to a ring that can slide up and down, that can slide up and down without friction, without friction on the road. Now the reflected pulse is not inverted by reflection. Now the inverted pulse is not inverted by reflection. Now in order to illustrate the reflection of waves at a boundary, we consider two situations. As we discussed above, in order to illustrate the reflection of waves at a boundary, we can consider two situations. We can consider two situations. We can consider two situations. First, a string is fixed. First, a string is fixed to a rigid wall, to a rigid wall at its left end as shown in fig. Left end as shown in figure 1 above. Secondly, the left end of the string is tied to a ring. The left end of the string is tied to the ring, which slides up and down without any friction on a rod, which can slide up and down without any friction in a rod. This will be illustrated in figure 1b. Now, a pulse is allowed to propagate in both these strings. A pulse is allowed to propagate in both these strings. The pulse on reaching the left end gets reflected. The state of disturbance in the string at various times is shown in fig 1. The state of disturbance in the string at various times is also shown in figure 1. Now, in figure 1a, the string is fixed to the wall at its left end. In figure 1a, the string is fixed to the wall at its left end. When the pulse arrives at that end, at that end, it exerts an upward force on the wall, by the Newton's third law, wall also exerts an equal and opposite force on the string. Now, due to the high mass of a wall, the wall would not be displaced from its place or move upward or downward either. The same energy which comes forward in a form of a wave and strike to the wall will be returned back into the just opposite phase of as an earlier it arrived to the next end. The wall exert